And are there any questions from anybody? No, okay. I just thought I'd do some reviewing today, so I'm not going to do. Our last session we had we talked about, I think, for loops. Is that correct? And I just thought we'd do some of the worksheet problems. We could even go over while loops. Maybe there some of the worksheet problems in the for loops are about converting from for loops to while loops. I did put up a few more problems today, and I put up another PDF file on for loops, which some of the examples, I'll let you know which ones to look at. And then I will post your test on Wednesday, and then you'll have a few days to, you'll have a choice of when to start it. So why don't we just get started then if there are no other questions. I'm going to look at that first for loop worksheet. Well, let's see here. So I'm going to share the screen. See if I can find this. Here, right here. And I also have Eclipse open. So it's kind of clunky. Yeah, we have to go back and forth between Eclipse and well, some of this I could just, this is a Word file. So some of this I can just type right in the Word file. Some of it, I think like number 4, why don't we try doing that one? And then number 4 is a good problem though, because we're going to be doing a lot of summation with for loops. Okay, so remember last time, so what are the 3 parts of a for loop header? Remember, so we'll see that a lot and you have to know these 3 to write a for loop. And so you remember a while loop, remember, was while. So let's see, can I write on this? Yes. So remember, so for while loops, it'll be like my whiteboard. So while, oh yes, it does that. Change that. So remember like a while loop, and then you had a Boolean expression. Remember, a Boolean expression is just something that's it's either true or false. There's no ambiguity. And then maybe you have statements in here. Okay, so that's for the while loop. So this is and somewhere in between the curly braces, we better do something that makes that Boolean expression false, or else that's just going to go on and on forever. Okay, and so then for the for loop, okay, so for loops are more what we see more. We see more for loops than while loops. So while loops are when we don't know the exact number of iterations. Like, oh, we're going to do something like computing a greatest common divisor, or parsing the individual numbers of an integer. We don't know how many numbers are in an integer. Okay, so that's when we use a while loop. Okay, so now let's just look at a for loop. So for, and again, for and while are keywords, meaning, they can't be used as a variable name, even though they consist of all alphabetic characters. And then you have these are the 3. I've some of this terminology, initializer, and then we have the Boolean expression, just like the while loop, and then we have I call it an incrementer, but it can really be anything. It can be a decrementer as well, or something that changes. We have this counter variable, and something that changes it. And again, then we have curly braces, and so as long as that Boolean expression is true, we execute what's in the Boolean expression. So you remember, this is what we learned last time. So the initializer executes one time. We start the for loop. This executes one time. Let's just review. And then how does the for loop work? Here I'll put. Okay, so then it's first we evaluate the Boolean. Whoops, doesn't like. How about 1? Okay, yeah, I'm using Microsoft Word. Okay, so 1. Okay, so then we remember it's the Boolean expression. We first evaluate the Boolean expression, and if that's true, then we go 2. We execute Java statements. Execute Java statements, and then 3. Then we do this in this order: 3, and then the incrementer, and then we go back to 1. And as long as the Boolean expression is true, if the Boolean expression is true, we go to step 2. So maybe I should say that. So if true, go to step 2. But so when I say what are the 3 parts, this is what I mean by the 3 parts right here. What are the 3 parts of a for loop header? And so we'll get used to writing that when we write our for loops. So it's a little bit more to memorize than a while loop just has while Boolean expression. And the for loop has all this other stuff built into it. It has the initializer, the Boolean expression, and the incrementer. Okay, so why don't we just look at some of these? Let's just do 2 and 3 in the let's just do 2 and 3 here in this Word document, and then we'll do number 4 and 5. Yeah, and then we'll do some more of these what are called counter, just kind of adding up. And then I have another worksheet as well, just similar problems, just a little more practice. Okay, so and I don't think we did I can't remember, to be honest. Okay, so his last ones. Okay, so write a for loop that displays the numbers 1 through 10. And then we're given the first few lines of output. So this would be a really good use of, now, if I just said write a loop, I would use a for loop because I know exactly the number of iterations, right? It's going to be 10. So it's not unknown. Okay, so, okay, so let's just try this right here. And I might get that word might capitalize, but we'll fix that. Okay, so here's our solution, and then I'll make sure a solution is posted up for this whole thing is posted this afternoon. Okay, so solution, and then so we use the keyword for, yeah, I knew it was going to do that. And then we just increment. So typically it's really common to use I or J. I know, let's see, I equals, yeah. So we'll just start at 1 in this case, because we're going to print out 1, 2, 3, and then it's I less than or equal to 10. It keeps doing that, doesn't it? And then our incrementer is going to be, because we're going in consecutive order. So let's see here. Do I have I think someone might be asking me something. Oh, okay, yeah, there's, yeah. Thank you, yeah, fix that. Okay, so then, yeah, thanks for that. And then, okay, so there we go. And then, yeah, so yeah, I plus plus. And I wanted to say one other thing in a minute here. I think I said it before in the notes. Okay, so we'll just do the system out print line. So I'm not going to get the double quotes that I get in Eclipse. So you have to go num is assigned, and then plus, in this case, I. Okay, so again, Eclipse is going to give you that straight up and down double quotes. If you actually copied and pasted this into Eclipse, yeah, it's going to complain about the double quotes. The one thing I will remember, I think I mentioned this last time, the book, I'll show you how they do it in the Zybook. And so this is Carl's, this is what to be honest, this is what most people do, what I just did. So the Zybook, for some reason, I don't quite understand why they take this approach. I think, yeah, some of it I do it. I think they explain why. Or I just want to make sure you will see this in this way in the Zybook, and they're equivalent. The Zybook would actually declare I outside the for loop. And then we're also going to review what happens when you declare a counter variable outside the for loop. No, I think they just declare like I here. They declare I outside the loop. I don't think they initialize it. And then in the for loop, there's where they'll go I is assigned 1. Then when we get into Eclipse, we'll see what happens, the difference between the two. And then everything else is almost the same. But they go plus plus I. So I don't know why. This is one thing I don't know why. That is really pretty much different than the rest of the world. They're the same. And for the way it's used right here, plus plus I means increased by 1. Remember at I plus plus means increase I by 1. Remember that? And it's in the context of which it's, people will talk about this on Wednesday, because Wednesday I'm not going to introduce any, we're going to start talking about arrays next. I think it's arrays next time, but I'm going to talk about kind of some things we haven't talked about on Wednesday. Maybe we'll talk about the plus plus and talk about switch statements and just some other things that maybe we haven't had time to talk about, but you don't have to worry about for your test. And also, I just want to say that plus I, if you put the plus plus to the left, it also means increase by 1. Now, you might think, well, what's the point if they're both the same? We'll learn on Wednesday. You can use it on the right side of an assignment statement, and then it's different. So someone's talking to me again. Yeah. So everything up till today will be on the test. So these kind of simple for loops, nothing super complicated. No, what do we? And then the contents are the same. So again, so the first version, this first version, if someone say, hey, write a for loop that prints num equals 1, num equals 2, num equals 3, num equals 3, they would write it, I think, like the way I initially did. And, and they might even use, I is typically a common, a counter variable. And then as I was typing, I was, the ZyBook does it a little bit differently. They take a little bit of a non-standard approach. And then we'll look at remember the difference between declaring I is declared in the first one. I is declared inside the for loop. The second one, the ZyBook approach, I is declared outside the for loop. And then we talked about this a little bit last time. When you declare I inside the loop, it can only be used inside the loop. If you declare I outside the loop, then it can be used after the for loop. We'll see. We'll just review that. So I don't know why. I think that's why they do it initially, because to reduce this aggravation. Though, if you actually go onto Math 140, they do. This is what you'd be expected to do. That first one. Okay. So let's just do the second one, and then we're going to go to Eclipse. Unless there are any questions or concerns from you, just shout out anytime in there or chat. Yeah. So a couple of you have been chatting. Yeah, they kind of lights up here, so I see it. Okay. So all right. Okay. So let's just do the second example, because this is an example. See here, I say incrementer, but it doesn't really have to be this third part here. The third part of the header. I plus plus could be, you could be subtracting, you can be increasing by 2 or increasing by 3. We don't have to increase by 1, or we don't have to decrease by 1. Okay, so I am just going to cut and paste, and I'm going to do my way, I guess, here. And then you can do, and on the quiz you can, or the test you can, or any kind of graded material, I don't care. Because if they showed in the book, that's fine. Okay. Let's just do this. We're going to go, and then we'll go for number 4. We'll go on and use we'll go to Eclipse. Okay. So I really made a mess there, didn't I? Okay. So now we're going to start. We want to start at 20 and go down to 1. Okay. So well, if the first value is 20, we have to start I out at 20. Okay. We want to stop. So we want the first value of I to be 20, the second one to be 19. We're going down. So instead of incrementing by 1, that's a minus minus. So I'm going to put, it's just a shorthand for decreasing by 1. It's really very common. Well, this Boolean expression, see that first of all, I less it right away, that would be false, because 20 less or equal to 10 is false. Okay, so we're going to go down. So and I'll fix that in a minute. Right, see, so now 20 so as long as I is greater than equal to 1, we're going to display. So initially, the value of I, the value of I is 20. Okay, that happens one time. We start I out at 20. And then and every time before we start the loop, you ask yourself, is I greater than or equal to 1? And the first time the answer is yes. 20 greater or equal to 1 is true. So then we'd actually would display num equals. And then remember we have that string concatenation. So remember that you take what's in the string, right? Num equals, that's in a string. So that just echoes perfectly. It just displays exactly what you see inside the double quotes, and then you concatenate on I. Here, I'll just remember it's going to be, let's say initially, remember that string concatenation. So the first time we'd see that, and that turns into the string. Remember, it just combines them. So we're actually remember, we're changing the definition of addition. We're just kind of concatenating, we're just combining. So we get the string. So the first time we print num equals 20. And then we decrease I by 1, and then you have to, so then I is 19. You ask yourself, is 19 greater or equal to 1? That's true. And so it actually executes 20 times, and then it's false. So the Boolean expression is false. The first time when I is 0, right? So eventually that Boolean expression must be false. Since 0. Okay, so are there any questions? If I don't hesitate to ask, because if you're confused, definitely ask. Okay, but I think it's the example. These are kind of relatively simple examples, but so these are 2. So 3 and 4 before you go on, or let's say when you're studying, you definitely want to make sure you know how to do 3 and 4. But if there are no questions on 3 or 4, if you want to talk to me, or if you want to talk to me later about it, that's fine as well. But let's do this very exciting problem, number 4. And so write a loop that finds the sum of all squares from 1 to 100. Okay, so we want to write once. There's actually I can't remember if we did this last time. Let's do it again anyway. There is a formula for this, which of course I didn't look up. Okay, so in other words, write a loop that computes the following sum. And then I have a couple in that second worksheet I just posted. I have another one, I think, sum the cubes. Okay, so and yeah, definitely let's just do this. And then we'll also just review what happens when you declare I outside the loop, or the counter variable inside the loop and the counter variable outside the loop. Okay, so let's just do this again in case I have this vague memory of actually doing this. Oh, we don't want to look at this. Okay, so let's. Okay, so we'll just call it, I don't know, something very exciting like test. And let's, I will put that in there. So Eclipse will automatically create the, let's get rid of that comment that it's created by Eclipse. Okay, so we want to find the sum of all squares from 1 to 100. So let me just kind of go down here. Yeah, I see some stuff from Zoom that's kind of blocking.
So we can't see your screen.
Oh, that's because I didn't share. Okay, that's the one thing I haven't learned how to do yet. Okay, thanks for reminding me. I think I go here. Oh, but wait a sec. Oh, because am I still sharing the old one? Yeah, I think okay, so let me, how do I get, okay, let's see here. So let's see here. I am, I think I need to go back here. Thank you. Yeah, stop. Yeah, I didn't stop sharing. Thank you. Okay, that's better. Okay. So okay, here we go. Yeah, well, I prepared, this is what you didn't see me do. I prepared this, and I'm just going to put my cursor here. Now, yes, so Zoom is kind of blocking part of my screen here. Okay, so we're going to find the sum of all squares from 1 to 100. And yeah, so there's a closed form formula for that, which I forgot to look up. And but I like this problem, and is a really common finding the sum of a bunch of numbers is something we'll be doing a lot in here, and it's something I do in Math 140, like finding. Let's say if you want to find an average, you have to first find, you have to find the sum of all the values, and then you divide by the number of values. So it's really very common to find the greatest value in a list or the smallest value in a list. If you want to sort, well, that's different. I'm talking about summing. Okay, yes, but I got off on a different topic. Yeah, but summing is something that's common for finding an average. That's really very important. Like if you want to get a grade point average. Okay, so let's just find the sum. I'm not sure there's real value in finding the sum of the first 100 squares, but let's do this anyway. It's a good practice. So the one thing in all summing problems, you need to have some variable to hold the sum, and let's make it meaningful. And then, and now we're going to do, so by the time we're done with the loop, sum will hold the value of the first, whatever, it doesn't have to be the first 100, whatever we want to add up, maybe the first 50 squares. And so so let's just do this. Let's define the counter variable inside the loop first. And then we'll see what happens if we try to use I outside the loop. So we want to go up to 100. So we're going to go in increments of 1. So remember that I plus plus means we're going to go in increments of 1. First I is 1, then 2, and then and so then we're just going to go sum is assigned sum plus, and we could use math.pow. But remember, math.pow is let's type that in. See how I declared sum as an integer? Let's try this. Math.pow. Remember I comma 2. It's 2 is the, so I is the base and 2 is the exponent. And now I have, but we don't, this is not our friend, is it? Anything red, when you're in Eclipse and it's red and there's like an X in it, yeah, danger. Yeah, danger. Okay. I mean, hopefully we're not really in danger, but not physical danger, hopefully. Type mismatch. Can you see that where it says that? This is actually a decent error message. Sometimes these error messages are so obscure. Type mismatch cannot convert from double to int. And what it is that math.pow returns a double value, like 1 squared. Like if you say 1 squared with math.pow, like math.pow 1 comma 2 returns 1.0. It doesn't return 1. There's a way of getting rid of that 0.0, which we'll talk about at the end of the year. There's something called casting, which actually rounds down. It would just truncate everything. It would just remove everything after the 0.0. But let's not do that now. It's a little bit too advanced for us at this point. Okay, so this is actually bad. If let's say you're taking a quiz or a test, you might think, oh, this works. Because you don't have maybe Eclipse in front of you. Let's say it's a Proctor test. But so the correct way to do this, we're just going to go sum is sum plus I times I. And now that works. And so remember, so again, that looks like that funny equation. Like if you subtract sum from both sides, you get 0 equals I squared, and then you get an F on your math test. Okay, but remember, it's not an equation. That equal symbol that we see on line 13, it's an assignment statement. You always start on the right side, calculate what's on the right, and then you assign that value to the left. So in this case, we're increasing sum by I times I. So every time, and then I is changing. Initially, I is 1. Right? So initially I is 1. 1 less equal to 100 is true. So you increase sum by 1 times 1. Then you come back up here to the I plus plus. increase that by 1, and then you check, well, is 2 less or equal to 100? And it is. So then you increase the sum by 4, and you keep doing that, and eventually, so stops when eventually I will become 101 when I is 101. And 101 less or equal to 100 is false. So let's actually print this out. Let's see what happens here. And then this is really great. So let's now I'll get the correct double quotes. Okay, so sum of first. So we print out a message, and then we need, let's put a space. So the plus. Oh, is this? Oh, so it's kind of weird since I'm working at home and I'm seeing my back. Yeah, it's kind of distracting. Yeah, it's just a bird flying by my window. Okay, but okay. So okay. So yeah. So remember we do that string concatenation. We start combining the number and the string. And let's just print this out. And then we'll just do a few changes. We'll just kind of experiment here after we're done with this. Yeah, so you get that huge number, 338,350. All right. I think it's like n squared, n plus 1 squared over 6 or something. I think that's the closed form formula. But I'd have to check that. Okay, so if you take calculus, you have to know that. Or first semester, and then you just you don't really use it a lot, so you forget it. Okay, so so students, let's just try. Are there any questions? Just shout out or chat, like some of you have.
Yeah, that question asks to write a loop. Can it be a while loop?
It can be. Now, if I was given this problem here, I would write a for loop because I know the exact number of iterations. But why don't we do that? Let's do that. We'll do that in a minute, okay? I want to do a couple more things with the for loop, and then we're going to write it as a while loop. So, but yeah, you could use actually a while loop. Sometimes I see students doing that, and it doesn't hurt to do it. That's the one thing I notice in Math 140 when I teach it. A lot of times the students, they're very uncomfortable. They're great with the for loops, and they're a little uncomfortable with the while loop because they really haven't had a lot of experience writing them. Because most problems that we deal with, we know the number of iterations ahead of time. At least that we deal with in Math 130 and even in Math 140. So I think, guys, there's only really 2 problems that I can think of that we've talked about in here, and that's the one that program that you just did, and also finding the greatest common divisor. And after that, most problems in Math 130 involve for loops. And there's a lot of for loops. But let's just do, I'm going to do just a couple of variations of this for loop, and then we're going to do the while loop version of it. Okay, so let's just comment this out here. Let's just do, because there's going to be a lot of output. Let's just do, I thought I turned it into a comment. Yeah, so to get the fast comments, I just highlighted all the lines, and then I did control /. And then to get rid of the comments, most of the time it works, you highlight the comments and you do the control / again. Okay, let's just do this. I guess I should have copied first. Okay, let's just print out. Let's just do the first 10. We're going to add up the first 10 squares. And let's just print out the intermediate sums. Okay, so, well, that wouldn't work. Gotta make sure to put some on both sides. And then what we're going to do is, let's just print out the intermediate sum. So then we can see then we can actually see some increment every time. Okay, so, okay. And the last sum should be the sum of all, okay, so yeah, okay, yeah. So sometimes putting a print line inside a for loop can help just so we can see what's going on. though typically when we're done with the program, we want to take the print line statement out, so we won't get all this output. Okay, so, all right, so we're gonna run as. Yeah, you can see how it's incrementing. First sum is 1, and then we add on 4, and then we add on 9, right? Because 9 plus 5 is 14. And then we add on, what do I say, 4? Then we add on 16, right? So then we add on 25. And so we eventually, so every iteration, we're adding on I squared. Okay, so I just want to see, so the sum is changing in every iteration. We're getting this partial sum. The first time it's the sum of the first square, then the sum of the first 2 squares, and then the sum of the first 3 and the first 4. And the very last iteration, we're getting the sum of the first 10 squares. And there's just one other thing that I just want to show us, or just kind of want to review, and then we'll do the while loop version of this. Okay, so remember let's talk, okay, so the Xi book doesn't like to declare, or that's the way they're teaching it. They declare the counter variable outside the loop, okay, and see how this is what I mean by declaring inside the loop. See how we're declaring I right inside the curly, not the curly braces. We're declaring I inside the parentheses, and that's what I mean declaring I inside the loop. Declare the variable in the loop. Okay, so if it's declared in the loop, and we're going to talk more about scope event, that's going to become an important part of the course. Sometimes variables aren't, I mean, we can see them in the code, but they're not visible throughout the program. It's like a door is being shut, the computer can't see it, just like someone walks into a room and they shut the door behind them, we can't see them. It's kind of like that. Okay, so I is not visible outside the for loop. Can I spell it? Visible. Yeah, sometimes I'm talking, I forget how to spell. No, that's a real problem for me. Okay, I is not visible outside the for loop. So let's just try this, and we'll see. We're going to get a red dot, the dreaded red dot, or we better get one. Print line I equals plus I. Uh-oh. What does that say? I cannot, what? I cannot be resolved to a variable. And okay, so if I was covering up the code there. So I is not, cannot, says I cannot be resolved to a variable. And you go, well, I is declared on line 19. So this is the kind of thing, if you don't know what's going on, it's just this rule, you either know it or you don't. And if you don't, and it's like 1 in the morning and you're trying to write your program, well, then you're really very sad. It's one of those aggravating things about computer science is there's all these tiny little gotchas that make your progress impossible if you don't know them. I mean, if you know them, then it's fine. This is one that people, we learn pretty fast, hopefully. Okay, so see where I say declare the variable in the loop. So I declared in the loop, and we talked about this last time briefly. I declared in the loop, so can only be used in the loop. And I think this is why the Xi book is kind of making life a little bit easy for us by, let's just avoid this issue. Let's not declare they don't declare their variables, at least initially they don't, declare their variables in the loop. And by doing so, yeah, you don't have to worry about this. Okay, so I'm just gonna comment this out. Okay, so I declared, so we can't actually run our program because now we have this compiler error. Okay, so remember, compiler error is it's this program that's kind of parsing our code, character by character, making sure everything is correct, and we're not using all the variable names are used declared, and we're not using any illegal characters. It's like a spell checker. It's like a kind of a more sophisticated spell checker. And so the compiler gets to this, you can't use it past line 20. See, you can't use I past line 22. So, okay, So I can only be used in the loop. Okay, so now I'm just gonna well, that fixes the problem. And now let's see the Zybook version of doing this. Okay, so hopefully you can see this. Zybook version. They declare I outside the loop. And I think they just go, I don't even think they give it a value. I can't remember now. And then they actually, I'm just going to cut and paste here. So now, see, now I get a compiler error. I'm going to, because I haven't changed something. So it says you've already declared I. Okay, so this is what the Zybook does. And yeah, so this is what the Zybook does. And so now we're fine, right? So now we're fine. So now I'm gonna, see, can I use I out after the loop? See, now we don't have that error anymore. See, I declared outside the loop. So in this case, I can be used this is one of those, this is why for loops can be, you know, if we don't know this is what makes for loops a little bit harder than while loops, because you have this extra rule. The for loops allow us to declare variables in the loop, but we're restricted. They're only visible inside the loop. Okay, so but when we declare I, like on line 32, we declare I before the loop. That means it can be used after the loop. So let's just, and we should see I equals 11 now when we print. Did I get rid of all my, I want to get rid of all this. I want to see this. Okay, so, okay. So we declare, yeah, it's kind of a mess at this point. Sum is 0. We declared on line 32, we just declare I out before the for loop. And then in our for loop, yeah, so we don't have that int, in the for loop, we don't see that int I. We've already said I is an integer, so you don't want to see if you say it again, it's kind of like insulted. It's like, oh, you already told me this. You already told me I is an integer, okay? So, okay, so now let's just run this. So we'll see all the sums, and then we should see I equals 11. Yeah, see, that's what makes that I equals 11. That's what makes the loop stop when I is 11. Yes, because eventually, are you still there? Wait a minute, what happened here? I don't see you. Oh, there we go. Okay. You can still see Eclipse, because for a second there, I saw the stop. I didn't see the stop sharing on the screen. Okay. Okay, but yeah, eventually I could, so yeah, did you see the output when I ran that?
Yes.
Okay. I have to be, I'm not in this Zoom sometimes kind of, I guess if I'm in the same application and then a new page comes up, you see, I just want to make sure. Okay, so that's but the one thing that's nice about this version of line 39, you can actually see the value of I that made the loop stop. Okay, so that's the one thing about all loops. You're doing all these comparisons, and eventually there's something that makes it false. Okay, okay, so we've seen the Zybook version of this for loop. We've seen the what I call the non-Zybook, kind of what I call this. To be honest, it's more the standard version. And now why don't we look at a while loop that does the same thing? Okay, so I'll just cover all this up here, and I'll scroll the screen up. So, okay, let's see here. So we're gonna, oh, it doesn't actually scroll up, does it? Okay, so let's just do this up here. We'll just, so I'm not at the bottom of the screen. So now we'll write, any for loop can be converted to a while loop. In fact, I have a couple of problems in the worksheet like that. Any for loop can be converted to a while loop, and any while loop can be, well, I shouldn't say any, to be honest, yes, any while loop can be converted to a for loop. You get this funny looking for loop, which we won't talk. Maybe we'll do that, one of those on Wednesday, that kind of Wednesday will be like a fun day. Not saying we're not having fun now, but our extra fun day. So, okay, so while loop. So here's the while loop version. Okay, so again, we're going to add up the sum of the first. We're just going to do a sum. So the thing about, remember when we calculate a sum, we have to have some variable to hold the sum, and then we're going to go. Let's say we're going to, and then we have to. Now you are forced to declare the counter variable outside the loop. The while loop doesn't have this mechanism where we can declare a variable inside the loop. All the while loop, remember the for loop has the 3 parts in the header, the initializer, the Boolean expression, the incrementer. In the while loop only has that middle part, the Boolean expression. So we've got to do all these other things manually. So let's declare our counter variable. Let's just call it I. We'll initialize it to 1. We have to initialize it now. And then let's just find the sum of the first, let's say the 100 squares, less than or equal to 100. We start I out 1. And as long as I is less than 100, we do what's in the Java statement. So sum is assigned sum plus I times I. So you can do the same thing. And then, yeah, and then we can just, I know it's kind of a mess here now because I'm doing all these examples in the same file. And now you'll get the exact same code. And you'll get the exact same result, hopefully. But I think this is what you were asking. Oh, wait a minute. No, I'm going to get a whole. Some of you are all probably thinking, or at least maybe some of you are thinking, what is he doing? I'm going to get an infinite loop. I'm not going to. Should we try running this and see? The problem is that I didn't increase I by 1. This isn't the trap you can fall into. When you're so used to writing for loops, you forget in the while loop, you have to do the incrementer. I starts out at 1, and there's nothing in my while loop going from lines 13, 14, and 15. There's nothing in there that increases I by 1. So every time you do that Boolean expression, we're going to go 1 less than or equal to 100 because I never changes. So right now, okay, I is always 1. So we get an infinite loop. It was not intentional. I caught it before I actually started running. Let's see what happens when we run it. And it should be, I'm not sure if the program eventually ends or we just have to force it to stop ourselves. Let's see. We're not actually seeing, yeah. Is it actually running? I'm surprised we didn't get the console. I don't see it. I thought we'd get the console if we did. Oh, no. Yeah. What happens if we. Actually, I think I made it run twice now. But yeah. But we're not actually seeing anything. I'm not sure if it actually stops on its own or if I have to force it to stop. And it's because I have that infinite loop. Here, let's just stop this. Okay, yeah, so we never get to line, we can't get to line 17. We're trapped. Okay, yeah, because 1 less than 100 is always true. Now let's fix that problem. Now we could go I++, or I could go I equals I, so increment I by 1, or we could do the I++ for our problem, or the plus I for this problem, it's the same. And now, so we took the infinite loop away. So I increment. So there's no I increments. Okay, no infinite loop. Okay, so and eventually I will get the value 101, and we'll stop. Okay, so I guess I would get the console when the program actually stops. Okay, so yeah, so you see the sum of the first 100 squares, and we get the same number. So let's just summarize again, because there's a lot of different things. So first we did this. The important part here was first we saw how to add up, compute a sum. we have to first declare a sum variable, and then in every iteration we go sum is assigned sum plus. And then we did the Zybook version of that where we declared the counter variable outside the loop. And then we, what else did we do? Oh, we saw that if you declare the counter variable inside the loop and use it outside the loop, you get a compiler error. And then we did a while loop version of it. So kind of a lot of different things going on here, but I'll put the solution file up for this, so it's in the Word file. But why don't we do a couple more of these? Are there any questions right now? There were a few problems in that worksheet where we're being asked to convert from a while loop to a for loop and vice versa. Why don't we try a couple of those? So let's stop sharing. So let's share again. Let's share. Let's go back to that. So just remember, if I don't take attendance. So if at any point, you feel like you've had enough, that's fine. But I'm not encouraging anyone to leave. But again, you're not going to hurt my feelings if you do. Okay, so I'm going to share the. Okay, so we did the first 4, and everyone sees this. Hopefully, where's the bar? Okay, so let's convert the while loop to a for loop and a for loop to a while loop. Okay, so let's just do this right here. Okay, so let's convert the while loop to a for loop. Okay, so in this case, the counter variable is I, right? And all it's printing out is, now in this case, it's printing out 0 through 9, right? The initial value of I is 0. And the value, so stops when I, isn't that, so stops when I is 10. Okay, so so here's our solution. Let's get rid of all the uppercase. So we initialize I to 0. So now we're going to use a for loop. So, oh, wait a minute, students, take it back. I'm not thinking. Let's do it I'm going to do it what I call the standard way. And then you can, that's where I declare the counter variable inside the loop. And so we're going to initialize inside the loop. We initialize I to 0, and then our Boolean expression that stays the same. I less than 10. So that's the one thing that stays the same. And then our incrementer is I plus plus. So let's just go I plus plus. And we can just copy this from the while loop. See the statements that we execute in the for loop are identical to the while loop. So notice that in the last thing we do, so the while loop kind of really makes it clear what the order is. Check the Boolean expression. If the Boolean expression is true, you execute that print line, and then you do the incrementer. It's the exact same order that that a for loop does executes. And check the Boolean expression. If true, execute like the print lines, and then the very last thing it does, we do the incrementer. So okay, so we just converted number 6 from a while loop to a for loop. Any questions on that one? Or okay, so now maybe we can just increment. How about this? Let's try some of these where we go from I'm having a hard time talking. and I'm just choosing this one at random. Let's just go from a for loop to a while loop. Okay, so now, again, this shouldn't be too bad, hopefully. So remember, in a while loop, we have to initialize, the while loop only has the Boolean expression. Okay, so our Boolean expression there is k greater than 1. K greater than 1. Okay, so that's going to be the Boolean expression for our while loop. And the last thing we'll do in our while loop is that k minus minus, right? Decrement k by 1. And then outside the while loop, we'll just, we actually have to write int k is assigned 10 outside the while loop. Okay, so let's just try this. So here's our solution. Okay, so initialize, I'm gonna have to fix it. It's gonna go, oh, didn't do the k uppercase, okay. Okay, so that's the initializer. Before the loop, because that's what you have to do in a while loop. You have to do the initializer before the loop, and then you write the keyword while, and then we have that Boolean expression. Take the Boolean expression from the for loop, and then the statement in the for loop goes right here. Oh, I see. I forgot the closing parenthesis. Okay, then. So if we look at the solution here, there's one thing that it's missing. Remember, we still have to do something to k to make that we have to do something to k to make the Boolean expression false, right? Because initially k is 10, 10 greater than 1 is true, and then we print out the value, the latest value of k, but we've never done anything to make k to make k less than 0, make k less than 1. Eventually, k better be less than 1, or the Boolean expression never ends, or the loop never ends. The Boolean expression is always true, right? So, again, we just take the last thing we're going to do, and that's the last thing we do in the for loop, right? The for loop is Boolean expression statements, and then this, in this case, it's a decrementer. So basically, we just have to reorder what we have in the for loop. The initializer goes before the while loop. Inside the while loop, we just have the Boolean expression. Then we have we have the statements of the for loop, and then we take that incrementer or decrementer and make that the very last thing of the while loop. And now, eventually, so stops when k is 0. Is that right? Yeah.
So a question on that one.
Yeah, go ahead.
If it stops when k is 0, should that be k is greater than or equal to 1?
Right, you're right. I'm sorry. Stops when k is what? How's that? You're right.
So
Yeah, greater than. Go ahead. I'm sorry. Go ahead, Richard.
The output would be 10 to 2, right? Not 10 to 1.
Yeah. You started. Yeah, you're absolutely right. I wasn't paying attention. Yeah. You're absolutely. Yeah. Thanks for that correction. So no, because otherwise it would confuse people. You're right. If it said k greater than or equal to 1, yeah, absolutely right. So it's So when k is 1, it stops. You're right. So it would print down to it would print down. Yeah, it would go from 10 to 2. Absolutely, you're absolutely correct. So thank you. Yeah, what I said before was wrong. Yeah, 1 greater than 1. So let's just write that out, since 1 greater than 1 is false. Okay, very good. Are there any other questions? I thought maybe we could do one more summing example, because we are going to see eventually what we're going to talk about. I think it's the next unit. I should have looked before. We have two big things. Let's see, what is this week? This is week 7. Is that right? And so we have about 8 more weeks, and then we do have that thing. We do have Thanksgiving, but we're going to talk about arrays and methods, and then we're going to do the object-oriented programming. So it's going to gradually. I'd say it does definitely get harder. I mean, we're going about to get, it's not so, I think if you study it, I'm not saying impossible, but it just requires more, maybe more time. And especially the last couple of weeks it gets kind of theoretical with this object-oriented programming. But we're going to do a lot of sums, not a lot. We're going to do a lot of loops, and we'll do sums, and we'll also do like looking for the greatest in a list and the smallest in a list. Okay, so why don't we, is it okay to do one more summation?
I think 5 might be a good one for multiples of 3.
This one right here? Yeah, okay. I thought I saw something like that. Yeah, that's a good one because it's a multiple problem. Okay, so in this case, first of all, where are we starting from? Because we're starting from 6, we're not starting from 3. Okay, so write a loop, and we can actually do both loops, okay, if we want. Okay, so but we're going to start the sum out at 0. Okay, so let's just do this in Eclipse, and I'll just start a new file. Okay, so write a loop that finds the sum of all multiples from 6 to 99. Let's just create a new file here. Oh, wait a minute, I have to stop sharing. I'm not going to make that same mistake twice. Okay, stop sharing. So now share. Where is my Eclipse? Right here. And now let's just create a new file. So I'm right-clicking, new class. And then I want the public static void main automatically for me. Let's just call this test2. We don't really care about the file name so much. Okay, yeah, so auto generates all this. And then, put in a package, which is not that big a deal. Okay, so, we're gonna write a loop that finds the multiples of 3 from 6 to, was it to 99? I think that was, let me take a look here. Yeah, okay. So again, whenever we're finding a sum, typically I think declaring a variable, nothing special about the word sum, except, it has meaning to us, has no meaning. You can call it anything you want. You can call it like X, Y, Z, and the computer doesn't care. Computer doesn't know what the word sum means. But we do. So we want to have meaningful variable name, because when you look at that variable name is to some degree self-documenting. You don't even have to write a comment for it. Sum, it's got to be holding a sum. Okay, so and then we're gonna write, let's just do 2 versions of this loop. Let's just write a for loop, and we're gonna find the multiples of 3 from 6 to 99. So in this case, let's just use k. There's nothing special about, I use I a lot. I just want to show you, it doesn't have to be int I. You declare a counter variable, any legitimate value. Any legitimate variable name, that's what I'm saying. A lot of times in these for loops, you use these single, this is one of the few times where I think using a single character variable name is good. But so we'll just go int k, and in this case, what do we say? We're going to start at 6, and then k less than or equal to, we're going to go all the way up to 99, and they're going in increments of 3. Because remember, this is our goal. So this is our goal. We want to add 6 plus 9 plus 12 plus 15 plus all the multiples of 3. So like plus 93. Yeah, so we're trying to find all the multiples of 3 from 6 to 99. Okay, so and let's see here. So we start, because our the initial term is going to be 6. So let's just start, okay, at 6. And we don't want to go past 99. So the Boolean expression, as long as k is less than or equal to 99, we continue. And let's just go in increments of 3. And now it's always the same, except we have to spell the word right. Sum is assigned sum plus k. So increment sum by K, right? You always start on the right side, which is sum plus K. You add those two values together, and then you assign it back to sum. So you're taking the old value of sum, increasing it by K, and then reassigning that to sum. And so defining the summation is just one line, because the for loop has that built-in mechanism for us where it has we declare the counter variable inside the for loop, and we write the incrementer inside the for loop. And then the while loop would have that K less or equal to 99. And then when we're done, we can actually just print out the value. Okay, so well, let's try this. Now that we've done all this hard work, let's see what the answer is. $1,680. Okay, well, that's interesting. Okay, so what's the interesting part is that we could do it, not so much increments of 3. Okay, so now we're very challenged, and we want to do the same thing with a while loop. And again, to go from again, this is a perfect example of, let's just talk about this just for just 1 minute. This is, again, a perfect example of why we'd want a for loop. We know the exact number of iterations. I mean, I can't really tell you. I mean, I could calculate in my head if I want to, but we know exactly when to stop. Okay, good, yeah. So, but it's going to be a fun. Every time you run this, I mean, you can actually easily write this on a sheet of paper and calculate the number of iterations. It's not some kind of unknown. Okay, so it's actually it's got to be 32, right? Because there's 33 multiples of 3 from 3 to 99, and we're not using the first one, so it's 32 iterations. So, but let's just practice using the while loop version. And the while loop, remember, the while loop says, okay, let's declare the counter variable before the while loop. Then we write while Boolean, there's our Boolean expression that K is assigned K plus 3. That'll be the last statement in the while loop. And this is what goes inside the while loop. So, okay, so I'm just gonna, okay, so now the while loop version of this, okay. So int K is assigned 6. And why 6? Because there's nothing, because that's what the problem said. Just start at 6 and add all the multiples of 3 starting at 6. And that just is a fun problem. And then we have our while, we use the keyword while, and then we have to put the Boolean expression in. Well, it's already written for us, K less or equal to 99. And then we just take the contents of the for loop. And again, now, oops, no semicolon. And now we actually have an infinite loop. And I'm kind of bad about this. I forget to put, I do forget to put the, inside the while loop, I have to write something to make it stop. Right now, K is 6, and I evaluate 6 less or equal to 99 as true. I add increment sum by K, and K never changes. So we'd evaluate 6 less than or equal to 99 over and over and over again, because we never make K change. But now we're going to do this. We're just going to take this last incrementer from the while loop. And now we'll get the exact same value. Yeah, we get the exact same number. So yeah, you could write a while loop version of it if you want. I think it's good to practice. I think it's definitely good to practice the while, because I do. Yeah, that's the one thing I have been surprised about when I started teaching Math 140. I mean, I taught Math 130 exclusively for a long time, and then I started teaching Math 140, and I was surprised about how many students this almost were kind of like, oh no, do they know while loops? It's like they're kind of good programmers, are just kind of like ambivalent about writing. They didn't have a lot of confidence in writing a while loop, so we definitely want to do both. But any questions right now on anything, I will definitely post the solution to all, I'll definitely make sure the work, I don't think I posted the solution to this. Oh, and I wanted just to show you one thing here. Is it okay to stop sharing? I did post, and I'm gonna make sure that we all, oh, I don't think I shared this. Let's see if I can find it, students. I posted a second, I can't, of course, I can't even find it now. I posted let's go back to, I was trying to find it. I posted a second PowerPoint slide on for loops, and I'll post an announcement. Some of those examples are not really appropriate for the test or the class. Knowing how to write but the first two examples in the second set of notes I put up, which I was more organized, I know where they are on my computer. I just put it up this morning and I forgot what folder it's in. The first two examples are good, examples of how to do a summation. So, so I'll make sure that all the solutions to the worksheet problems so if you see something in a worksheet that's not, real simple, either like, let's print out like one, number equals 1 from 1 to 10, or number equals, 20 down to 1, or finding a summation, it won't be on the test. But also the thing about their test, unlike normally that I would have, it is open book, right? But I'll make it very clear what to study. So, because you don't really want to start studying, when you open the questions like, oh, I don't know how to do this. And if you have to start doing a lot of studying, it's one thing to jog your memory. It's another thing to, I have no idea how to do this, and now I'm going to start studying. That's probably not a good way. You're not going to do well if that's the case. So you definitely want to prepare beforehand. So if you can do all the worksheet problems, that'd be, that I'm going to recommend. Basically, it's all the worksheet problems. If you can do the quizzes, the worksheet problems that I put up, like the recommended worksheet problems that I put up to prepare for the quizzes, and then I'll post something. It's basically what I said today, but I'll put it in writing. The kind of the for loop problems that we did today. Finding a summation and just doing some simple printing, like 1 to a 10 or 10 down to 1. But any questions on anything?
Yeah, I had something.
Yeah, go ahead.
So you're posting the quiz Wednesday, correct?
Yeah, I'll post the exam on Wednesday, and then you'll have several days. You'll have a choice of several days of when to start.
Okay. Well, was quiz 5 going to be graded by that point?
Didn't I? Yeah. So quiz 5. Yeah, I'll grade. When was quiz? Yes, absolutely. I'll grade it tomorrow.
And by that time frame, should quiz 3, 4, and 5 be open so we can view?
Oh, aren't they open? Okay, if they aren't open, I'll double check to make sure they're open. I thought, I'm
only 1 and 2.
I'm kind of absent-minded, so I'll double check. I did put all the solution files up yesterday.
Yeah, I saw those.
Okay, so then I'll put the solution file up for 5 tomorrow morning. And as soon as I get off of here, and yeah, if don't hesitate to write me, hey, that quiz is closed. And it does actually help me, to be honest, because I get distracted. Someone writes me like there's a crisis, and then did you submit this for, or, someone asks me for help and I get distracted. Yeah, don't hesitate. If there's something, I'll keep all the quizzes open. I'll definitely do that. So I'll go back and make sure that they're open.
Thank you.
I'm hearing my cat. Okay. Anybody else want to have a question right now? So I will stay here until everyone's gone. I'll be the last one to leave the room. And then, let's see here. I might ask someone a question.
Have a good one.
Yes, sir. I had a question
Yeah,
on the last lab in Zybook.
Oh, okay. Oh, you had a question on the last lab?
Yeah, I had tried to do that one, but I didn't understand. It was asking a while statement for the max. I forgot which one, but it was asking for a max.
Oh, yeah. Do you have any code or anything, Daisy, or?
It's not. I do, I think, but it's inside Zybooks. I don't know if it saves it though.
Okay, yeah. Oh, I think it does say your code. If you wanted to share your screen with me, if you wanted to, or we could just, there's an example. my cat's getting annoyed with me. Okay, so yeah, you might hear a cat crying. Okay, So let's see, let me change the security so you can share if you want. Oh, I'm gonna stop recording, okay?